that already. This another 3 weeks. This week, next week, and next to next week. I will be continuing for another half an hour to 45 minutes. Okay, because to complete the syllabus, I need to take extra hours. Otherwise, it's not possible to complete the syllabus. So please bear with me. So today also I'll be extending the class. So now we'll move into Boolean difference symbolic method. This is a combinational ATPG algorithm. ATPG stands for Automatic Test Pattern Generation Algorithm. Using this algorithm for any given circuit, for any specified fault in the circuit, only one fault at a time, remember, I can generate the test vector, which will be detecting the fault which is specified in the circuit. So using ATPG algorithms, the aim is to find the test vector. Okay, like that, what will be the aim of the fault simulation algorithms? Aim of the ATPG algorithm is to find the test vector which detects the specified fault. What will be the aim of the fault simulation algorithm? Here I told we will find the test vector. There,
The false
To
is it
test
detectable
whether
or
faults
not?
are detectable.
Any who's that talking now?
We'll find if the faults are detectable or not, ma'am.
Faults are detectable or not. For what? For any given? Anybody else? I could get some other answer from somebody else also. Now I heard from Priyanka. Anybody else? Please respond.
Using this, you can you can identify the test vectors when input is the fault. Unlike the previous algorithm where the test vectors are already given.
No, I want the objective of a fault simulator algorithms. I defined the objective. Listen here, I defined the objective of this ATPG algorithm. ATPG algorithms are used to find the test vector which will detect the specified fault. Like that, can you define the objective of the fault simulator algorithms?
To test whether it is detectable or not, whether the faults are detectable or not.
To test whether the faults are detectable or not, it's incomplete. Something need to be added with the sentence.
For a given test vector, if a fault is detectable.
Yeah, for a given test vector. So the objective of the fault simulation algorithms are to check whether the given test vector can test the given faults or not, or specified faults or not. So test vector is also given, fault is also given, circuit is also given in the fault simulator algorithm. So your aim is to check and tell whether this test vector detects this fault or not. But in ATPG algorithms, please understand students, please listen to the class. In ATPG algorithm, the objective is to find the test vector. Test vector is not given to you. Find the test vector which will detect the fault which is given in the circuit. But when you do this analysis, I've listed out many types of ATPG algorithm. In all these ATPG algorithm, you need to consider the faults one by one only. The algorithm have to run for one fault one times only. Like each and every fault have to be considered individually. So in this order, last class we started with the Boolean difference method. So in the Boolean difference symbolic method, we took this circuit, and in this circuit fault is specified, and you can see this is only one single fault. So I can proceed with this algorithm. So as per this algorithm, first we need to get the Boolean expression for the final output. Here the output variable is y. So I got the expression. Next step is, as per the algorithm, we need to find dou y by dou b. Why b here is, Fault is given in the primary input B. So that's why do B. If fault is given in the primary input A means I will write here do Y by do A. And here Y represents the output variable. So if output variable is X, I will write it as do X by do B. So the denominator variable is written with respect to where the fault is present, and numerator variable is nothing but your output variable. So next we have to substitute in the Boolean expression which we got for the fault variable 0 and 1. That is why B of 0 means in the Boolean expression which we have for Y, we need to substitute B as 0, and YB of 1 means we need to substitute B as 1. So whatever expression we are getting after substituting B as 0 and B as 1, we need to XOR it. When you XOR it, you will get a final expression. So when you XOR it, we got AC bar plus AD bar. With this, I need to multiply the variable B. Either I need to multiply the variable B as such or B bar. That depends upon fault which is present here. If the fault is 0, I need to multiply with B. If the fault is 1, I need to multiply with B bar. Same condition wherever may be the fault. If fault is present in A, if the fault is 1, I need to multiply with A bar. If the fault is 0, I need to multiply with A. Here the fault is 0, so I multiplied with B into do Y by do B. So similarly with this expression also I need to multiply B. But remember, when you get this expression should be in SOP form. And in each term, each product term, the variables have to be written in a proper order. ABCD means ABCD. XYZ means XYZ. X1, X2, X3 means X1, X2, X3. In the order it has to be written. So after writing that in order, for each variable we need to assign either 1 or 0. If the variable is not there, you have to consider it as X. So in this case, A is 1, B 1. If it is bar, you need to consider as 0. And the third variable D, because in your circuit if you see there are 4 variables. D is missing in this product term. So D is not there. So you have to consider it as X. So A1, B1, C is not there. B bar is there, 0. So 1, 1, 0, X, X0 are the test vector which is going to detect the fault stuck at 0 at B. So this will be your answer. Is it clear? So in the last class, I asked you to find the answer for this. Correct? So Y will be AB plus BC plus AC. Next, do Y by do C. I asked you to consider the fault at the input, not at the fan out branch. I asked you to consider at the input. So YC of 0 plus YC of 1. What is YC of 0? Did you get AB? YC
Yes,
of 0 is AB. YC of 1 will be AB plus B plus A. Did you get this?
Yes,
yes,
ma'am.
ma'am.
Next, when you XOR it, what you are getting?
A bar B plus B bar A.
A bar B plus B bar A. Okay. This is it in sum of product term?
Yes, ma'am.
Yes. Okay. Whatever this is what required, it is there. It is in SOP form. Next, we need to multiply. For stuck at 0 fault, I need to multiply with C. So I will get A bar B C, A B bar C. What will be the test vector?
0, 1, 1 and 1, 0, 1.
Yeah, 0, 1, 1 and 1, 0, 1 is the test vector to test the fault stuck at 0 at C. And for stuck at 1 fault, I need to multiply with C bar. So what are the test vectors?
0, 1, 0 and 1, 0, 0.
0, 1, 0, 1, 0, 0 are the test vectors. Did I tell anything else?
For B also you have to
For
find.
B also.
What is the answer? Wait, wait. Who's that now talking? Sumalata, tell me.
When we consider stuck at 0 at B, 0, 1, 1 and 1, 1, 0, ma'am.
0, 1, 1, 1, 1, 0. Others, anybody else can give the answer? Is it the same?
Yes, ma'am, it's the same.
Okay,
The
Anusha,
stuck
can
at
you
one.
give answer for the other one? Anusha?
Is it B is stuck at 1 1
Ah,
and yeah.
yes.
It will be 0 0 1 and 1 0 0.
Okay, Priyanka, are you getting this answer?
Yes, ma'am, the same.
Kirti, are you getting this answer?
Yes, ma'am.
Are you getting this answer?
Yes, ma'am.
Bharat?
Yes, ma'am.
Meher? Meher?
Ma'am, I didn't get that answer, ma'am.
Did you solve the problem?
Yes, ma'am. Last class I was absent, but I have solved with the help of recording.
So solve it. If you have any doubt, you can ask me at the end of the class, okay?
Okay, ma'am.
Gautam, did you get this answer?
Yes, ma'am.
Nikita, Prashant, did you get this answer?
Yes, ma'am.
Kuber,
Yes, ma'am.
Jaswant,
Yes,
Jaswant,
ma'am.
Raymond, Raymond, Anjani, Haris,
Yes, ma'am. Doing, ma'am.
doing. I asked you to complete.
Not doing. I mean, like, nothing.
Huh. Surya Lohit, Surya Lohit, Asis, Venkata Asis,
Yes, ma'am. I got it. Hello. Hello, ma'am.
Surya Lohit, you got it.
Yes, ma'am.
Asis, Venkata Asis, Dinesh, Veda
Yes, ma'am.
Vyas, Raymond Pavan is answering. Did you get the
Yes.
answer?
Doing, ma'am.
Doing, ma'am. When did I ask? When did I ask you to do? Now doing, ma'am. Huh? Raymond, when did I ask you to do? Last week, Thursday, I gave.
Yes, ma'am.
Kept your laptop for puja?
No, ma'am.
No, then you should have completed. I thought you will give that excuse. That is acceptable.
Ma'am. Doing.
Doing. Did you understood how to solve this problem? Sai Krishna, Harikala
Yes,
Sai
ma'am.
Krishna,
Yes, ma'am.
solved the problem.
Yes, ma'am. Solved.
Are you getting this answer?
Yes, ma'am.
Yes, ma'am. Yes, ma'am. So shall we move on to the next algorithm, Sai Krishna?
Yes, ma'am.
Okay. So Sai Krishna have told, so we are moving to the next algorithm. The drawback with the current Boolean difference symbolic method is, I gave you two problems, right? In both the problem, where did I specify the fault? I think the problem I have told you in the last class. What is the problem here?
Ma'am, fault is at primary inputs.
Fault at the primary inputs are only testable. Like for that, those faults only I can get the test vector. If the fault is present at the output, or the fault is present at any other fan out branch, or any other intermediate points, using this algorithm, I cannot get the test vector for those faults. So because of the drawback, we move on to the next type of next method, path sensitization method. So because of that, we go for path sensitization method. Students, please listen. In this method, there are three steps. First step is fault sensitization or activation or excitation. Second thing is fault propagation or path sensitization. Third step is line justification. I think you can see this. See the three steps name of that in the slide. So remember, there are many different names. But you basically remember 3 steps as sensitization, propagation, line justification. Remember these 3 things you should remember. Other names later you can remember. But as of now, to understand how this algorithm works and how we are going to get the test vector, you should remember this. First step is fault sensitization. Second step is fault propagation. And third step is line justification. Okay. Now, before we start with the sensitization, propagation, and justification, one more thing we need to do. Okay. Suppose this is the circuit given to you, and this is the fault specified in the circuit. Chuck at 0 fault at the primary input B. Now, the first step before we start with the sensitization, propagation, and line justification, before this, the very first thing you need to do with the path sensitization method is look at the fault site. That means look at the circuit and check it out where the fault is present. Fault is present at B, stuck at 0. For this fault to propagate, to go through or to travel through the circuit and reach the primary output, how many paths are there? How many paths are there? For this fault to reach the output, how many paths are there? One fault is F, B, F, H, K, L. Another path is B, G, I, J, K, L. Another third fault is through both, simultaneously traveling through both. So totally how many paths? One is 3. One is F, L. Another one is G, I, J, K, L. Then F, both F, H, K, L and G, I, J, K, L, both parallelly. Okay.
3 paths.
3 paths are there. Remember, if there is like a path like this fan out branch, you need to consider the third path as both together. Remember, you need to consider both together. Suppose if a fault is present at C, how many paths are there? Fault is present at C. How many here? Primary input C. How many paths are there?
One only, no.
Only one. Yeah, only one. C, I, J, K, L. Only one. If it is at A, also only one. If it is at E, only one. If it is J, it can be anywhere in this algorithm. Remember, fault can be anywhere. If it is present at J,
Only one, mom.
Only one path. So first we have to list out what are the paths available. Then for each path, we need to do all these 3. For each path, we need to do all these 3 things. We need to do sensitization, we need to do propagation, and we need to do justification. Okay. So in this way, now let us take our first path, F, H, K, L. And remember here and all I have written 1, 1, 1, 1, 1. This I have already assigned a text I have added here to make you understand how it works. But actually you will be given with a circuit without this one. Remember, don't think that this one and all will be present already. This I have just added and kept for me to explain you. Okay. Is it clear, students? Only the circuit, blank circuit will be given to you with the variables and fault. This 1, 1, 1, for me to make the work easier, I just kept these things ready. Okay. Now let us take the first path FHKL. For the path FHKL, I need to do fault sensitization, propagation, and line justification. So first fault sensitization. Let me take the path FHKL, and my first step is sensitization. Sensitization means sensitization, or you can remember this word also, activation. Activation means here, what is this fault present here? What is this fault present here?
Stuck at 0.
So fault is stuck at 0. If my B value is 0, will there be effect of the fault seen in my circuit?
No, mom.
When my fault will be active, when I assign an opposite value for that particular signal line. If a fault is stuck at 0, to activate that fault, that particular signal line should carry opposite value 1. Only then the effect of fault I can visualize at the output. If the fault is 0 and that line is also actual value which is traveling through the line is also 0, will I be able to visualize that fault at the output?
No, ma'am.
No. Understand, students? It's not possible. So to activate the fault, that is our first step. Whatever fault is present, opposite value we have to assign to that particular signal line. It can be a primary input or any intermediate or output, anywhere. Okay, so now the fault is 0. If I want to activate the fault, this particular signal line, which is nothing but B, should hold the value 1 or 0.
1.
1. So I gave here 1. So this is 1. This is the first step. So now we have done the fault activation. Next step, fault propagation. I need to take this fault to the output. That is known as fault propagation. I need to take this fault to the output. So now through which path? The considered path is FHKL. Through this path, I need to take the fault. Now here at this particular node, what will be my fault? 1 is now stuck at 0. 1/0. 1/0, we will represent it as D or D bar as per D calculus.
D.
1/0, we will represent it as D. So G also will be having D or any other value. Because fault is here at the stem. That fault effect will be there in both the fan out branches, F and G. So F also will be D, G also will be D. But as of now, we are considering only the path FHKL. So let me concentrate only in this path. Now tell me, students, F is now D. I want to take this fault. Now D is a fault. I need to propagate this fault. I need to take this fault to H. I need to get here D. If I want to get here D, what should be my A? This is an AND gate. What should be my A? 1 or 0? Think and tell. My F is D.
1.
If it is 1, D into 1, D I will get. If it is 0,
0 we will get.
0 we will get. So I need to make it 1. So I made this 1, I got here. Now this D, I need to take it to K. I'm just taking it to the output through the consider path. If I want to get K as D, what should be my J? What should be?
0.
This is an OR gate. 0, correct. So 0 plus D will be D. Who gave this answer now? Who gave this answer now? Give your name.
Manish, ma'am.
Manish. Okay. Okay, Manish. Now this D, if I want to take it to L, what should be my E?
1.
1.
This is an AND gate, so 1. So whether we have propagated the fault to the output, is that success? Yes, it's success. We have activated the fault, that was success. We have propagated our fault through the also success. Third step is line justification. Line justification means here to propagate D from K to L, I assumed E to be 1. I considered E to be 1. But I need to now check, go backward and check whether is it possible to give E as 1. Here I made J as 0. Now I need to check whether I can give J as 1. Sorry, J as 0. So this process is known as line justification. I need to justify. Is it possible to take J as 0? Is it possible to take E as 1? Is it possible to take A as 1? So this is known as line justification, the third step. So when you do the line justification, you have to travel from backward to from the output to the input. Backwards. From the output to the input, you need to travel. This we call it as tracking. This we call it as a backtracking. So when we do line justification, we are actually performing backtracking. Okay, now let me start the line justification. We are able to propagate, it is success. Now, can I have E as 1? Yeah, possible. Primary input. I can have E as 1. So this is justified. Now coming to this OR gate. Can I have J as 0? If I want to have J as 0, my I should be 1. Correct, students? If I want to have J as 0, my I should be 1. Okay. Can I have I as 1?
No, ma'am.
Why?
Here we get D, ma'am, from input. C is equal to 1 and Z is equal to D.
Okay, I can change this C. If I make this as 0, is it possible?
No, ma'am.
Then also not possible. Students, are you able to understand? Here I need 1. If I get 1 only, I will get J as 0. Is it possible to get 1? I cannot change this D because it is a fan out branch. Fan out branch purely depends upon the stem. In the stem, we have the fault. So this will be definitely D. I cannot change this. I can play with C because this is a primary input. If my C is 0, I will get I as 0. If C is 1, I will get I as D. So I failed to get the line justification. I failed to proceed with the line justification. So my conclusion, I cannot propagate my fault. Sorry, I cannot get the test vector for the given fault using the path FHKL. I succeeded with the activation. Okay, I'll say we succeeded with activation. We succeeded with the propagation, but we failed in the line justification. For which path? FHKL. So now this path is ruled out. I cannot get the test vector. Next, let me check with the next path. As of now, let me keep this on hold. Second path, let me keep hold. Let me move on to the third path. Okay, students, now let us move on to the third path. Again, for the third path also, you need to go with 3 steps. First, activation. Stuck at 0 fault, I activated by making B as 1. So when I make B as 1, F will be D, G will be D. Now remember, we need to take both the paths simultaneously. So from F, I need to take this D to HD. So what should be A? 1 or 0? I'm doing it again from first, remember. F is D, 1. At the same time, from GD, I need to take it to I. What should be my C? Simultaneously, I need to propagate.
1.
1. Okay. Now, this is D. What will be my J?
D bar.
Okay.
D bar.
What will be my K now?
1, ma'am.
1. Are we able to propagate the path now? Sorry, fault now. If I say I need to propagate the fault, remember, I need to take either D or D bar to the output. I forgot to tell you this. If I say I'm propagating my fault to the output, remember, you need to take it to the output either D or D bar. This is not there now. I started propagating through both the paths simultaneously. Here I got K as 1. Fault is present here, and that fault, when it is propagating through both the faults, I got K as 1. So we succeeded in our propagation or we failed?
Failed, ma'am.
Failed. We failed in the propagation. So this path cannot be used. So this also ruled out. So remember, student, in the first path, we failed in the line justification. In the second path, we considered we failed with the fault propagation. So anything can happen. So we need to check path by path. The third one also ruled out, we didn't get the answer. First one also ruled out, we didn't get the answer. Now let us try with the second one. Now let us try with the second one. Let me delete everything, then only then you will understand. Okay. Okay, now freshly I'm starting with the second path. Each and every path you have to take it as a fresh. So second path GIJKL. Fault is here. I need to activate it. So I made that 1. Now because it is 1, both the fan node will be having D and D. Now my aim is to propagate through GIJKL. So let me concentrate only in this path. So from G, this D has to come here. If I should get I as D, what should be my C?
1.
1. So if I is D means J will be
D bar.
D bar.
D bar. Somewhere that is missing. Okay. Right. Okay, J will be D bar. So I need to get here. K will be now. This D bar I need to bring. Okay, it's, for propagation, remember D or D bar, I need to take it to the output. So this D bar, if I want to take it here, what should be my H?
0.
It should be 0. Okay. And this D bar, if I want to take it to the output, L,
E should be equal to
E should be? E should be?
1.
1. Whether we are able to propagate now? Are we able to propagate the fault?
Yes, ma'am.
Yes, ma'am.
Yes. Can we now go with the line justification? Yes. D bar, if I want to get here D bar, E should be 1. Yeah, primary input can kept as 1. Next, if I should get K as D bar, H should be 0. If H should be 0, what should be my A? Tell me, students. What should be my A?
0.
A should be 0. B primary input I can keep as 1. C. So everything is done now. Line justification is also successful. What is the test vector which is going to test our fault stuck at 0? What is the test vector?
0, 1, 1.
0, 1, 1, 1. That is A, B, C, D is equal to 0, 1, 1, 1. So this is our final test vector. So now you all remember, by default always, if I want to propagate a fault with an AND gate, other inputs would be? If I want to propagate a fault in a 2-input AND gate, other inputs would be for propagation 1. Remember,
1.
for OR gate, the other inputs would be
0.
0. Remember, for NAND gate,
0.
0 or 1? NAND gate. Our constraint is I can either propagate D or D bar, not an issue for me. So for an AND gate, if one of the input is D and other input is 1, what will be my output? For 2-input NAND gate, one input is D, other input is 1. What will be my output?
D bar.
D bar, correct. If the other input is 0,
1.
so which I should use? 0 or 1?
1, ma'am.
1. Remember, students, for AND gate and NAND gate, the other input should be 1. If it is an AND gate, means D means I will get D. D bar means I will get D bar. But if it is a NAND gate, opposite I will get. D means D bar. D bar means D. Is it clear? But the other input line AND or NAND, it should be 1. for propagation. For a OR gate, OR or NOR, other inputs would be 0. If it is a OR, please note down in your notebook. If it is an OR, other input will be 0. D means I will get D. D bar means I will get D bar at the output. If it is an OR gate, other inputs would be 0. D means I will get D bar at the output. If it is D bar at the input, I will get D at the output. Opposite. Is it clear? How about XOR and XNOR? 1 or 0 other input, or it can be anything. In an XOR gate, one input is D. The other input is 1. What will be the output? 2 input XOR, one input is D, other input is 1. What will be the output?
1.
Is it 1? Think. Consider like this. Suppose
No,
one
ma'am,
of
it cannot be determined, ma'am, actually.
see, one of the input, one means you consider as 1/1. Okay, and this is one of the input. Other input I told D, right? D, how I can write like this in this format? Can I write 1/0? Assume you have an XOR, 2 input XOR gate here. Look at the slide. 1, I'm writing it as 1/1. D, I'm 1/0. So what will be my XOR output? 1, 1, my output will be 0. 1, 0, my output will be 1. So for D, if my other input is 1, I'm getting D bar. Students, are you able to understand? D, I'm writing in this format, 1/0. 1, I'm writing it as 1/1. So when I XOR, actually what is this? Fault free with faulty. So 1 into 1 XOR 1 will be 0. 1 XOR 0 will be 1. So when other input is 1, for D, I'm getting D bar. If the other input is 0, if other input is 0, what will be my output? 1 into 0 will be 1. 0 into 0 will be 1. So which I need to use? I'm getting 1 finally. Students, are you able to understand whatever I'm telling now?
Mom, can you please repeat, Mom?
See, assume that here you have an XOR gate. Okay, I could not. Just a minute. Assume that there is a 2 input XOR gate. Okay. Now these are the 2 inputs. One input is D. Can I write D as 1/0? Tell me. Can I write D as 1/0? Correct. In the place of 1, we have a 0 fault. That we represented as D. Correct. So 1 is nothing but the true value. 0 is nothing but the value. If anything represented in this form in VLSI testing, that is the indication. Above this slash, this is the fault free value and this is the faulty value. 0 is the faulty value. So D I can represent like this. Other input is suppose 1. This 1 I can write it as 1/1. My true value is also 1. That is my original value is also 1. Faulty value is also 1. So when I XOR it, true value first let me XOR. 1 XOR 1 will be 0. 1 XOR 0 will be 1. So this 0/ is what? Can I say it is a D bar? Can I say 0/1 as a D bar?
Yes.
For 0, I am getting 1. It is a D bar. So when the other input is 1, for the D, at the output, I am getting D bar. Let me check with 0 now. This is 0. This is also 0. So 1 XOR 1, sorry, 1 XOR 0 will be 1. 0 XOR 0 will be
0.
0. So that time I made a mistake, huh? In that case, yeah. 0 XOR 1 will be 1, correct? 0 XOR 0 will be 0. So for D, I'm getting at the output D when I add 0. So what is the conclusion here? Can I use either 0 or 1 in the other input line? If I add 0, I will get D as such. If I have 1, I will get D bar. So can I have 0 or 1? Yes, we can have 0 or 1. Anything I can have for a XOR and similarly for XNOR. So remember, AND gate and NAND gate, the other inputs should be 1. OR gate and NOR gate, the other input should be 0. For XOR and XNOR, the other input, it can be 0 or 1. Anything you can use. Clear?
Yes,
now, take this circuit. Take this circuit. Here, fault is at E. Fault is present at E, stuck at 0. Using path sensitization method, for the fault stuck at 0 at E, find the test vector. So fault is at E. How we can proceed? Fault here, it is stuck at 0. Remember students, first step is to find out how many paths are there. How many paths are there?
1.
Only one path. What is that path?
EH.
H.
K.
Only one path is there. Okay. Next, for this path, I need to do activation. Suppose fault is stuck at 0, fault at E. So somewhere here, the fault is stuck at 0 fault. If the fault is stuck at 0, how my E value, that is output of this NAND gate, should be 1 or 0 to activate the fault. Output of the NAND gate should be 1 or 0 to activate the fault.
1.
1, because fault is 0. Fault is 0. Remember students, fault is 0. So the output of the NAND gate should be 1. So as of now, I'm not thinking whether I will get here 1 or not. I'm just assuming that I have activated the fault. My output of the NAND gate is 1. So my output of the NAND gate is 1. Assume that here you have a fault stuck at 0. So after the fault, which is now going to enter this OR gate, what is that value?
D.
D. Because I activated with 1, fault is here stuck at 0, so this is D. This now activation is completed. Next I need to propagate the fault. This D, I need to take it to H. What should be my D? Small d.
0.
0, because this is OR gate, so this should be 0. Hope all others are also listening. Now this D, I need to take it to K. What should be my F? What should be my F if I want to take H to K? This is an AND gate. So the other input should be
1.
1. 1. Propagation is done now. Whether the propagation is done?
Yes.
Now we need to think of line justification. Can I get 1 here? First line justification, backtracking. Can I get F as 1? If I need to get F as 1, what should be these two values?
0, 1 or 1, 0.
Okay, let me take 0 and 1. So if this is 0, my C is 0. Correct? I'm getting the C only here. So this, if C is 0, this also should be 0. The second line, if this should be 1, my B should be 1. Okay, B is 1. So this line is also 1. This line is also 1. So here I did line justification. Now coming to this point, E. Can I get E as 1? I cannot change because B and C is fixed as per this F. B and C is fixed as per this F. So based on this B and C, whatever I fixed now, 1, 0, NAND gate output will be 1,
1.
Okay, 1. So we are getting. So this line justification also completed. Now go on here. Can I get D as 0? This B is fixed. I cannot change this one. Only possibility is A. Tell me. If I want to get D as 0, what should be my A? I can play with A now.
0.
0. Line justification is done. Now, tell me whether we have completed the line justification. Yes, I guess. Yes, we have done. So here possibility is 0, 1. You can even take 1, 0. If you take 1, 0, what is the test vector we are getting, students? So now my answer will be A, B, C is equal to 0, 1, 0. If I take 1, 0, are you getting the same answer, students? See, 1, let me try. 1, this is 0. So this line is my B line. So complete B, I need to change it to 0. 0, this is 0. And this line is my 1, 0, no? So this is 1. So C line should be 1. So 0, 1, NAND gate output, I will get it as 1. So no issues. Here, B should be 0. With B value 0 itself, I will get D as 0. So this can be X. Students, are you able to understand? With this already set B value as 0 itself, I will get D as 0. Correct? So A can be anything. Yes or no? Can we have A anything? Because with this 0 itself, I will get this 0. So the test vector is, if I consider 1, 0, my test vector will be, comma, X, 0, 1. So for testing the fault E stuck at 0, I got totally how many test vectors? Totally how many test vectors I got? 0, 1, 0 is 1. 0, 0, 1 is 1. Correct. 1, 0, 1. 3 test vectors I got finally. The answer for this problem. So this, but exam point of view, if you give any one answer, it's fine for me. But in this circuit, for the given circuit, there is only one path. No issues for you. You will complete fast. If you have 3 faults, sorry, 3 paths or 2 paths or 4 paths, whatever may be, for all the paths, you need to do these steps. If the question is, I have given, consider all the paths, then you have to definitely consider all the paths and you have to solve the problem. If I have not specified, consider all the paths, nothing has been given. Question is using path sensitization method for the given fault in the circuit, find the test vector. Now, if in that case, there is 3 paths in your circuit. First path you are taking, you got the output in the first path itself. Stop it. Go ahead with the next question. Because I didn't specify, I didn't ask you to consider all the paths. I've just asked you for the answer. In that case, even though multiple paths are there, then again, that depends upon again your luck. Which path you are taking first. The first path you have taken, that gives in using that path itself, if you are getting the output, go ahead with the next question. With that path, if you are not getting the output, you need to check with the second path. If I have not specified in the question, consider all the paths. Please note down in your notebook. Is it clear? So for tomorrow's homework, same circuit, using path sensitization method. Using path sensitization method for the fault stuck at 0 at C here. Listen here, students, here. Fault here. Okay. Fault is here. Are you able to see whatever I'm doing in the slide?
Yes.
So fault here using path sensitization method for the fault stuck at 0 at get the test vector. How many paths are there for this?
2.
2 or
3,
3?
ma'am. 3. 3.
Yeah. H, K. And here variable is not given. The top one, the bottom one, and the third one is both.
Simultaneous.
Simultaneously. 3 paths are there. So you have to consider 3 paths and you have to get the answer. If time permits, you can take the same circuit and one more question you can see in the slide using Boolean difference method for the fault stuck at 1 at A also you can practice if you have time. Boolean difference method for A. So now this is about the path sensitization. Any doubt? Any doubt, students? What are the 3 steps?
Activation, propagation, justification.
Activation, propagation, justification. For each and every path you need to do. Sometimes you may fail in propagation, sometimes you may fail with justification. Sometimes this fail may happen with all the paths. That means you will not get answer only. That also can happen. Okay. So now, can you tell me what is the drawback with this method? Boolean difference, it cannot test the false which is present at intermediate or output. So that is the drawback. In this, what is the drawback? Can anyone tell me what is the drawback here? Time consuming? It's not a drawback. One by one paths we are taking, paths one by one we are considering, we are sensitizing and we are considering. Correct, students? So note down
Yes.
the drawback. Path sensitization is that. Please note down. Path sensitization is that only one path is sensitized at a time. Only one path is sensitized at a time. This is first drawback. Only one path is sensitized at a time. Next drawback, does not guarantee. Next drawback, does not guarantee that a test will be found. Does not guarantee that a test will be found for a fault even if one path exists. For a fault, even if one path exists. That means even if one path is there, I'm not sure I will get my answer. So that is the second drawback. First thing, one by one I'm sensitizing, so it takes time. Second thing, if one path is there also, I'm not sure whether I will get the answer. Third problem, test pattern generated may not be unique. Test pattern generated may not be unique. May not be unique in the sense we took this fault, here E stuck at 0. How many test vectors I got?
3.
I got 3. I'm not getting 1, which is very unique. I'm getting multiple answers. So that is said to be the third problem. So these are the 3 issues with the which method? Path sensitization method. Because of that, we move on to D algorithm. D algorithm. In D algorithm, there are 3 steps: singular cover, propagation D cube, primitive D cube of failures. Otherwise, we call it as PDF. Okay. Among all the numericals, this is the one which is lengthy. But initial steps will remain same for all the any type of circuits. But if this problem is given, this problem will be little bit lengthy. Depends upon if the number of gates in the circuit increases, how much you need to work on also will increase. But remember students, initial steps are default fixed. Whatever may be the circuit, how many big circuits I give, for each and every gate present in the circuit, the procedure you need to follow remains same. Okay, so 3 steps here: singular cover, propagation D cube. So now third step is primitive D cube of failures. This third step I need to proceed with a specific circuit given to me. So I am not going to explain you this today. Today I am going to explain you only singular cover and propagation D cube. How to get the singular cover, how to get the propagation D cube for all the gates. All the gates in the sense, I will explain you how to get this for an AND gate, OR gate, NAND and NOR. Singular cover and propagation D cube I cannot get for a NOT gate. Remember students, I cannot get it for the NOT gate. I can write this only for AND, NAND, OR, NOR. For XOR and XNOR, singular cover is not possible. Only propagation D cube is possible. Remember, for XOR and XNOR, singular cover is not possible. Only propagation D cube is possible. So now, let me take 2 input AND gate, and for a 2 input AND gate, now I am going to explain you how to get the singular cover and propagation D cube. Shall I proceed, students? Shall I proceed?
Yes.
Are you all listening?
Yes, ma'am. Yes.
Okay, please listen. All these topics are there for the end semester, so please listen. So now, 2 input AND gate. First, what I have to do is I have to write the truth table. 2 input truth table: 0, 0, 0, 1, 1, 0, 1, 1. What will be the output? AND gate output: 0, 0, 0. This is 0, this is 0, this is 1. I wrote the truth table for a 2 input AND gate. Next step, this table I have kept to tell you how to get the singular cover for a 2 input AND gate. I'll explain you. Please listen. Look at this truth table. With respect to the output, in the output I have output as either 0 or output as 1. Okay, let me now split this into 2 groups. Let me now split this into 2 groups. First group is the group with output 0 and the other one is group with output 1. Group with output 0 and group with output 1. Okay, next. So if I split it into 2 groups, group will have these 3 things. So let me highlight with red color. This is another group with output 1. Let me highlight this with green color. So green color is one group, red color is another group. Now what I am going to do is, within the red color where I have maximum combinations, 3 combinations, within this red color, I am going to take each pair, maybe these 2 first, I am going to get one combination. Next I will consider these 2 together and I will get one answer. Next, first and third I will consider and I will write one answer. Okay. Let me consider first and second. Students, I am taking these 2. First, A, both are 0. Next, 0, 1. Here both are 0. A, B, C, sorry, A, B, Y. How many variable is differing?
1.
Only one variable is differing, that is B. So I can consider this. So what I will write is, when I consider these 2, I will write it here it as 0. 0, 1 is varying for B. So I will write here X and next is 0. Now let me consider second and third. How many variable is differing? 2 variable. A is 0, 1, B is 1, 0, Y is only same. 2 variable is differing, so I cannot consider that. Okay, next 1 and 2 is done, 2 and 3 is done. Now can I consider 1 and 3? 1 and 3. How many variable is differing? 0, 1, 0, 0, 0, 0. How many variable is differing? 1 and 3 if I consider. 1 variable. So I can consider that. So A is varying. So X, B is 0, 0, Y is 0. Done. So this is done. So I splitted the truth table into 2 groups with the values 0 one side and 1 one side. I took the maximum count 1, all zeros. So between this, I have 3 combinations. So I compared in the 3, 1, 2, 2, 3, 1, 3. All I compared. With that, I got this. So this group is completed. Now move on to the other group, 1, 1, 1. That as such you fill here. So this is the singular cover. So this is the singular cover. Now let me do it for a OR gate. 0, 0, 0, 1, 1, 0, 1, 1. What will be my output? 0, 1, 1, 1. I've written the truth table for an OR gate. Let me split it into 2 groups. So this is one group. These 3 under one group. So the group with only one combination, let us not consider now. Group with many combination only I need to first consider. So here I need to consider first and second. So when I consider first and second, how many variable are differing?
2.
2. Can I consider that now in the singular cover? No. Okay. Now second and third, only one variable is differing, so I can consider. So let me write here 1, X, 1. Now 1 and 3, 0, 1, 1, 1, 1, 1.
X 1.
So
Only
X,
one change.
1, 1. So this group is done. Other group which I have only one combination, that values as such, I need to write it here. Now everybody fast, write the singular cover for NAND and OR. Everybody please write the singular cover for NAND and NOR. If you have any doubt, you can ask me. NAND truth table 1. I made a mistake. This is R, right? R truth table, right?
Yes, ma'am.
Okay, this is NORPA. Do it for NAND. You do it for NAND and NOR. Okay, NAND and NOR. Okay. So this is one group. This is one group. And this is Haris, can you give me the answer now? Haris?
Ma'am, I have a doubt.
Yeah.
Ma'am, when we're writing the singular cover, does the order matter?
No, nothing. No issues.
Okay, ma'am.
Ma'am, 1 second, ma'am.
Write the singular cover for NAND. What, Haris?
Yes, ma'am. 110.
NAND.
Yes.
110. Singular cover? Okay, fine. 110. Okay. Next.
X11.
X11.
Yes, ma'am.
Which two? 1 and 2 or 2 and 3 or 1 and 3? Where you are getting X11?
Ma'am, X for A, B for 1, and Y for 1, ma'am.
That's what I'm asking. Here 3 combinations. To see the slides?
Yes, ma'am.
Which two when you combine, you are getting X11, 1 and 2 or 2 and 3 or 1 and 3 rows? Which rows if you combine, you are getting X11?
Ma'am, 2 and 3, ma'am.
2 and 3. Can I combine 2 and 3? Second row and third row? We cannot, right? Because two variables are changing, so I cannot combine. If I combine first and second row, what you will get?
First and second row will get 0, then X, then 1, ma'am.
Okay.
0 and
0. 1 and 3.
And 1 and 1. 1 and 3. 1 and 3 will be X, 0, 1, ma'am.
Now have we understood how to do this?
Yes, ma'am.
Gautam, tell me for NOR gate. G Gautam. He's not there in the class. Gautam is not there in the class.
Yes, ma'am. Yes, ma'am. 1 minute.
For NOR gate. What happened, Gautam? Now I'm going to the other person now. Vinita. B section, Vinita.
Yes, ma'am.
Can you tell? What is the singular cover for NOR gate?
X10, ma'am.
Okay.
1 don't get 0.
1 X. Okay.
0, 0, 1, ma'am.
Okay. Gautam, are you getting this?
No, ma'am. I made one mistake, ma'am.
Okay. But it's clear, right? How to solve this?
Yes, ma'am. Yes, ma'am. I'm checking, ma'am.
Okay. Now, hope all others also have now understood how to get the singular cover. Only these 4 gates will be there in the circuit. I already told you, NOT gate, we cannot write anything. We cannot do anything with a NOT gate as such we need to consider. For XOR and XNOR, I told you singular cover is not possible. So in any circuit, whichever I give you, will have any of these 4 gates only. So this is default. If you are not understanding how to write the singular cover, at least mug up it. Hope you would have understood that necessity won't be there. Okay. So for all gates in a circuit,
Ma'am, what did you say for NOT gate, ma'am?
NOT gate, nothing, no singular cover, not propagate, nothing could be done. As such, we can do it. Take it in the circuit. I'll tell you that. When you take a bigger circuit and we proceeded, you will understand.
Okay, ma'am.
Now for the gates, this is default, this is fixed. Actually, this D algorithm I'm not going to do with respect to gates. I'm going to do it for a bigger circuit only. So in the circuit, obviously, you will have these gates only. So for each and every gate have to be separately taken and it has to be handled in this way. So remember, D algorithm means you should know how to get the singular cover for all these 4, because any one of these gate will be there in your circuit. So that's why I'm giving the explanation starting with the gate so that you will understand. So singular cover for the gates, hope you guys would have understood now. Now next is the propagation DQ, which we need to do from the singular cover. This is little bit confusing, but it is easy to remember. Okay. Now here also let me divide it into 2 groups. This is one group and this is one group. Now compare the rows in green color with red color. Compare the rows in green color with red color, or I can compare the rows in red color with green. Anything I can do, any way I can do. First, let me consider from green to, first let me consider red to green. Let me take this red. Compare it with first row. 1, 0, 1, X, 1, 0. 1, 0. Actually here, this red color is set to, has to be considered as the value of a good machine or a good gate. Some gate which is fault free is giving the value as 1, 1, 1. That value we are comparing with a bad value, that is 0, x 0. So good value is compared with a bad value. That is what we are doing here. When I compare 1 with 0, I will get D or D bar. This is good, this is bad. That means 1/0. That is D or D bar. D. 1/0 is D. I'm considering this as first. Red as first. Comparing with green color. So 1/0 is D. 1x, I need to consider it as 1. 1/0 as D. First row and third row is done. Now third row you compare it with the second one. 1x will be 1. 1/0 is D. And 1/0 is D. Any doubt in this?
Ma'am, can you repeat?
This values, whatever I have here, let me split it into 2 groups again with respect to the output only. These 2 combinations have output 0, so I can as one group, and these 2 combination have, this combination have output 1, so this as one group. So 2 groups. So what I'm doing here is this group with only one combination, I'm comparing with each combinations in the group in green color. So third row I'm comparing with the first row. Third row I need to consider that value as a first value. 1/0. D, right? At the place of 1, if we are getting 0, we will represent it as D. So 1/0, I'm taking it as D. 1/x, x can be anything, so I'm considering it as 1. 1/0, I'm considering it as D. Similarly, 1/x. Now I'm comparing third with the second one. 1/x as 1, 1/0 as d, 1/0 as d. Here, this is one group. This is another group. So this group with a single combination, I'm comparing with others. So 0/1, 0/1, third row and first row. 0/1, I have to write it as d or d bar? D bar. 0/x, 0. 0/1, d bar. Next, third and second, 0x, 0, 0/1, d bar, 0/1, d bar. Is it clear now? Is it clear, students, now?
Yes.
Next, one more is there. Now, this one, the combination with one, the line row with only one combination, I compared with the other one. Next, what we have to do, this comparison is completed now. This one you have, right? Only one combination we have, right? What will be the opposite value for this combination? 0, 0, 0. Am I right, students? 1, 1, 1. Opposite value will be 0, 0, 0. So opposite value we need to consider as a bad gate value. So that means in place of 1, I'm getting 0. In place of 1, I'm getting 0. In place of 1, I'm getting 0. In place of 1, if I'm getting 0, that is D or D bar? D.
D, ma'am.
D. D. So this is said to be the propagation D cube. This propagation D cube can also be written as, so using the method, whatever I told you, students, using the method, whatever I told you, you get this propagation D cube. Next, we can get one more propagation D cube also for this. If I explain that, it will be a confusion. So what I'm telling is how to get the other propagation D cube with whatever you have already got. Listen here, this one and all you should keep as such. Suppose here, if you have D, change it to D bar. Wherever you have D, change it to D bar. Wherever you have a D bar, change it to D. That's it. 1 and 0 keep as such. Don't do anything. In the propagation D cube, for this is also known as propagation D cube table. This is also known as a propagation D cube table for a 2-input AND gate. So this I explained you how to get. The first table I explained you how to get. Second table also we can get it. Second, directly looking at this singular cover. But if I tell you, it will be a confusion for you. So that's why I'm telling directly when you get the one propagation D cube, from this you get the other one. How you will get the other one is, per cells is having 0 and 1, don't touch that. Wherever you have D, change it to D bar. If you have a D bar, change it to D. I'll explain you with another one. So what will be the last one? Can you tell me now here? 0, 0, 0. Opposite value will be 1, 1, 1. D bar, D bar, D bar. So what will be the other propagation D cube table?
Instead of D bar, take D.
Instead of D bar, take D. That's it. The 0 will be as such. The 0 will be as such. So these are the propagation D cube for. Now fast write. I'll close the today's session. Complete the propagation D cube for NAND. If you didn't understand, please ask me. Fast write the propagation D cube for NAND and NOR? If anybody already have the answer, you can tell me. So this I can divide it into two groups. This is one group and this is group. So the single, this is the single one. Compare the first one with the second, compare the first one with third. So when I compare the first one with the second, I will get anyone? When I compare the first one with the second, what I will get?
D1 D bar.
D1 D bar. Good. Next, when I compare the first and third,
1D D bar.
1D D bar. Okay. Last one, 110. Opposite will be 001. So
D D bar.
D D bar. The other propagation D cube. Other propagation D cube. So wherever I have D bar to D to D bar to D to D bar to D. This is the other propagation D cube. Now coming to this. Anyone from A section? Anyone from A section, can you answer for this? I want the answer from A section students.
D bar 0 D.
D bar. This is combining third row with?
Third row with the second row, ma'am.
Third row with the second row. Okay, third row D bar?
0
Okay.
D.
Oh, okay. Next.
Then it is 0 D bar D.
Who's this giving the answer? I'm not in this.
Anusha, ma'am.
Okay, Anusha. Okay, next one.
D bar D.
Okay. So what will be the other propagation D cube? Wherever I have D bar to D to D bar to D to D bar to D bar to D to D bar. Clear, students? So you should remember this. All the 4 gates, mainly these 4 gates, mostly the circuits which we will deal with I will take with these 4 gates only, because this is lengthy one. So I'm telling you, definitely I will make it minimal circuit only. If I give a bigger circuit, then your A4 size papers won't be sufficient. Okay, now we got the singular cover and propagation DQ for AND, NAND, NOR, and OR. Okay. For XOR and XNOR, I told you the singular cover is not possible, only propagation DQ is possible. That we will see little later. Suppose if a circuit is given to you like this. In the circuit, which gates are there? Fault is not specified. I will give the fault. If this is a circuit given to you and I have asked you to use the D algorithm, what are the gates present in the circuit?
NAND gates.
Only NAND gate. So remember, if I want to solve this circuit using D algorithm, I should know the singular cover and propagation D cube of NAND gate. Suppose if I have a NAND and OR, that means to solve this circuit, I need the singular cover and propagation D cube of NAND and OR. So whatever gate is present in the circuit, those gates singular cover and propagation DQ we need. Only with that I can solve this problem. But singular cover and propagation DQ is always same because truth table is fixed. If truth table is fixed, singular cover is fixed. Singular cover is fixed, propagation DQ is also fixed. So this singular cover and propagation DQ for all these 4 gates will not change. Fixed. If you know, at least suppose in the exam, the circuit is given, you have to attempt this. Mainly I'm telling this question and concurrent. Always you have to attempt at the end only because that is a bigger one. So if you are attempting this one, at least if you could, for the gates present in the circuit, if you could write the singular cover and propagation DQ, you will get some marks. So like this, you need to create a table. So tomorrow's class, I'll tell what to do next. How to do the D algorithm. Basic, I told you. When you use the D algorithm, you should know that particular gate, singular cover and propagation DQ. How to get the singular cover and propagation DQ, I explained you already. Now for the given circuit, using that input, how to solve it, I will tell you in tomorrow's class. Okay? Is it clear, students?
Yes, ma'am.
Yes, ma'am.
So one homework is there, remember. And one more thing, Excel sheet is shared with you, right? Did anyone open that Excel sheet, assignment Excel sheet?
Yes, ma'am.
What is the number given to you?
3.
3. So when you go to your AEMS, in the assignment, now it is posted around 11:30. I posted. Now in your account, the question paper will be there. In some question papers, there will be 5 questions, depending upon. Check it out. So how, and for each question, there is sometimes number will be given, sometimes alphabets will be given. So in this Excel sheet, I'll just share the Excel sheet now. So in this Excel sheet, suppose for Neelima, it is C, means you in your AEMS account in the subject 15 EC369, inside the assignment, you will get one question paper. In that question paper, for which question the variable is C, that question you need to take and solve it and submit. Suppose for Surya Lokit, in whatever question paper you got, in that question paper, the question number 14 you need to solve. For Ganesh, question number B4 you need to solve. That is that. For Sarfaraz, B1 you need to solve. So in whichever question paper you are getting, in that question paper, definitely D1 or 5 or 6 or E will be there definitely. So that question alone you need to solve. Okay. In that question, if you have any problem and if you have any doubt, you can personally send me in the Teams the question. If there is any confusion, hope there won't be. In chances are also there may be some confusion. You clarify with me if you find any problem. For everyone, as of now, the question paper will be reflected in your AEMS account. So go download that question paper, and as per the Excel sheet, which question you need to solve, look, check that number, that question alone, you solve it, and your deadline already posted in the Teams. Deadline is coming Friday evening 6 o'clock. By today evening or tomorrow morning, I will share the MS forms. So in that MS forms, you need to upload. Any doubt in this? Your assignments you need to upload in the MS forms link. If you have any doubt in your question, if any variable is missing or anything is missing, please personally message me. I'll sort it out. It's shared in the post, Teams post, 15 EC369 Teams. In the post I have in the files I have uploaded it.
Yes, ma'am. Files.
Okay.
In files I have uploaded it.
It's there.
Okay. So across your name, that only. If you do some other question, no, I won't accept. 15 marks for this. Neatly solve it. 4 days time is there. Neatly solve it. Copy down the question properly from the question paper. Your question, not other, your friend's question. Your question alone, that you need to copy down. And you have to solve it and upload it. Any doubts, students? You can see you have questions on fault equivalence, fault dominance, deductive, concurrent, parallel fault, event driven, reduce algorithm. That's it. Differential. Yeah. Differential also not there, I think. No, differential also not there. I didn't get differential also. Only this much I have given. But each one will get different circuits. Okay? Is it clear? If you have any doubt, if there is any confusion, anybody, can you check fast in AEMS? Is the question paper reflected?
It's there, ma'am.
Okay. So correctly match it. Whatever Kirti, the same number, or which is the number for you?
2, ma'am. I've got it.
Okay, fine. So that way you need to match. There should not be any confusion. Okay, students, thank you.
Ma'am, also for quiz, what are the questions, ma'am?
Quiz, I didn't tell you, na. Quiz, fault equivalence, fault dominance, that topic. Okay, for the quiz, fault equivalence and fault dominance, that topic. There also we have checked, is it redundant fault or not, equivalent fault or not, all these things. Fault equivalence, fault dominance, checkpoint theorem. This one, is it a redundant fault or not? Is it equivalent fault or not? Then can I add BDD also? It will be easy for the NSEM. BDD also. Is it okay? Okay, BDD, anyway, you people, depends upon. BDD, Shannon's alone, can I give? Shannon's method alone? Shannon's and reduce alone? Answer me. I'm talking to you guys only. Or only with first topics 5 enough? What happened, Pa? Am I audible?
Yes,
Students,
ma'am.
am I audible? Now tell me.
Yes, ma'am.
See, anyway, all these topics are there for the NSEM. Definitely BDD and ATPG, Pakka, it is there for the NSEM. Okay, leave then. Only those first BDD you learn later. Okay, so syllabus coming Tuesday, right? Coming Tuesday, the test quiz 2. Quiz 2 will be, I will be conducting in that mostly in AEMS using that test mode. MCQs but MCQs if I give also, you need to give the justification that in the paper have to be uploaded. Okay, paper need to be uploaded. I'll look into. Anybody else planned a quiz and how did they conduct? Any other subject?
We'll have one quiz, ma'am. After that, we'll tell you, ma'am.
Which subject?
Information theory, ma'am.
Okay, then tell me. Based on that, I will decide. What did they tell? What way?
Sir told it will be a mix, ma'am, but not sure.
Okay, even I'm planning like mix MCQs, descriptive, everything. But you need to do it on the teams and you need to solve it. How you are solving, how you got with an answer for that MCQ, that proof need to be uploaded. Something like that only we have been asked to do. Okay, syllabus is this. Equivalence, dominance, checkpoint. Is the fault is a redundant fault or not? Is the faults present in the circuit is equivalent fault or not? 5 topics. Anjani, are you there? Sri Anjani, are you there? Anjani Kumar, are you there?
Yes, ma'am. Yes, ma'am.
How did you do midterm test? Why are you
Not
laughing?
sure, ma'am.
Not sure. You didn't do well.
Like the answers which I got, I was not sure like whether they do it right or wrong.
You are getting full mark, yaar. 30 out of 30. Good. You got 30 out of 30. Only one guy. Few more are there. Around 18 booklets. Mostly tomorrow I will release midterm marks. Anjani, you got 30 out of 30. Good.
Thank you, ma'am.
Okay. Bye, students.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you.